It is true that 10 comes after 9 and comes just before 11. It is also true that 10 can be conceived as a collection of 10 separate ones, or as a unit in its own right. I have heard it said that a complete concept of 10 requires understanding of its relationship to 100, that 100 is made up from 10 tens. Hi, my name is Robert Hunting. This is one of several in a series explaining how children learn mathematics. If there is one message to take away from this discussion, it is this. Children think differently about 10 than do adults. I will illustrate this clearly by reference to examples of one child's thinking over a period of 2.5 years. First, Luca, aged 4 years and 8 months, is seen sitting in front of a bead frame and is asked what 10 and 10 more is. Okay, do you know what 10 and 10 is?
10.
You know what 10 and 10 more is? Like, if I put 10 over here, right, and another 10, do you know how many beads that is altogether? You want to count them?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, so there's 10 here and 10 here.
I don't know what that is still.
Notice that he counts the top row by ones. Then he counts the second row, also beginning with 1. He seems unable to say what the total is. The interviewer asks Luca an easier question. What is 10 beads and 1 more? And explicitly says, we'll put 10 over here, as he slides the top row of 10 beads across the frame. Let me ask you this question. What's 10 beads and 1 more? So if I put 10 over here and put 1 more over here, how many is that?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11. All right, very good. In the end, as we will see, although Luca is told each row contains 10 beads, and he is encouraged to count the beads in the second row, starting from 11, he insists on counting each bead in the first row again, continuing the second row beginning at 11. So if I put that there, and that's 10, and that's another 10, can we count from 10 on, like this? 10, 11,
12, 3, 1, to there, 2 to there, 3 to there, 4 to there, and 5 to there, and 6 to there, and 7 to there, 8 to there, and 9 to there, and 10 to there,
10. Now keep going. 10.
11,
Mm-hmm.
12, 13, 14, 15,
Okay.
16, 17, 18, 19, 20.
It is clear that the information provided to Luca that each row contains 10 beads has no useful numerical meaning for him, because he proceeds to count the 2 rows of beads as just that, a collection of 2 sets of 10 single beads. In the next example, Luca, at age 5 years and 4 months, is asked to figure out how many beads are hidden behind a screen when a number of beads in a row are made visible. What do I do?
I'm going to put these all down here. I'm going to put this here, like that. Alright, and now watch this. I'm going to show you some beads. No, you can't go peeking. No sneak peeks. No. Now you see if you can tell me. Now, if I put this bead here, in this row,
It's not good.
do you know how many more beads are hiding?
I haven't counted first.
Oh, you want to count them first? Right, we'll count them first.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Do you know how many's here without counting? On this row?
What?
Without counting, can you tell me? No, you don't need to do that. That's counting. I can tell, you're looking. Go on, you can count them.
1, 2, 3. Okay, 1, 2, 3, 4.
Start again.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
What is striking is that despite the fact that to the observer each row contains 10 beads, as measured by the similarity between rows, Luca decides to count all the beads on the third row, even though he had just previously counted 2 rows of 10. 18 months later, we observe different thinking. Luca is now 6 years and 10 months.
How many beads are there in this row?
10.
How many beads in this row?
10.
How many beads are there in this row?
10.
How many beads? How many beads in these 2 rows together?
20.
Oh, how many beads in these 4 rows together?
40.
Ooh, how many beads in these 5 rows together?
50.
All right. How many beads in these rows all together?
100.
Oh, wow.
He is able to confidently state the number of beads in various numbers of rows of 10 up to 100 and beyond. A revealing task for gaining an insight into a 6 to 9-year-old's conception of 10 is the following. I prepared a flashcard with the numeral 43 written on it and gathered a number of wooden pop sticks, 6 bundles, 10 tied together with rubber bands, and 12 to 14 loose single sticks. Luca was told that each bundle contained 10 sticks and was invited to verify the number in each bundle.
Now, how many sticks are in each bundle, do you know?
10?
Are you sure?
Yes.
You don't want to check them?
I know there's 10.
You know. Oh, all right, you know there's 10. All right, and okay, now here's what I want you to do. See these sticks here? I'm going to show you a card with a number on it. Okay, and I want you to make that number with the sticks. Can you do that? Can you tell me what that number is?
43.
Can you make that number with the sticks? Oh, champion. How do you know that's 43?
Because 4 bundles of 10 makes 40, and then there's 3 more, makes 43.
Excellent.
Luca was 7 years and 2 months here. He showed that he was able to conceive of 10 as an iterable unit. He showed a much more robust understanding of 10 compared to what we observed on earlier occasions. You can learn more about this topic in chapters 4 and 5 of my book, What Children Can Teach Adults About Mathematics, and in my book, The How and Why of Teaching Elementary Mathematics. Copies may be obtained from the iTunes Store, Amazon.com or Google Books. There are links to these sources on my website, www.palm-ed.com, and you can visit my Facebook page at www.facebook.com/HelloPalm.